What if I told you that China is already building the worker that will erect a human base on the moon, and that worker is not human? While the world was debating artificial intelligence models and chatbots, Chinese engineers published a project that could forever change the way humanity colonizes space. A robot with a waist that rotates 180 degrees, hands capable of manipulating scientific instruments, and wheels designed to withstand the most extreme cold in existence. The space race of the 21st century will not be won by astronauts. It will be won by machines. Want to understand everything? Then watch the video all the way to the end and I'll explain it all. But first, leave your like and subscribe to the channel. China presented the world with a concept that blends science fiction with cutting-edge engineering. A semi-humanoid robot on wheels, designed specifically to work on the surface of the moon. What nobody expected was for this project to be so detailed and so close to becoming reality. We are not talking about just any experimental prototype. The research group responsible is linked to China's official space program, and the stated objective is to prepare this robot to enter service as part of the International Lunar Research Station, the ILRS, which Beijing plans to build by 2035. That is less than 10 years from now. The machine's design is intentionally hybrid. Instead of completely imitating the human form, like the bipedal robots that Boston Dynamics made famous, the engineers opted for a more practical solution. The upper body has the agility of a humanoid, with articulated arms and a waist capable of rotating about 180 degrees to each side and bending up to 90 degrees forward. This flexibility allows the robot to reach different positions with tools without needing to reposition the entire structure. Its articulated hand has 4 degrees of freedom, which in simple terms means it can perform precise movements on 4 independent axes, enough to tighten screws, handle lunar soil samples, and operate scientific equipment. The lower part is completely different from the humanoid robots we are used to seeing. Instead of legs, the project features a wheeled locomotion system equipped with active suspension, a mechanism that automatically adjusts the height and inclination of each wheel as the terrain changes. The reason for this choice is simple. The surface of the moon has no asphalt. It is covered with craters, rocks, dust as fine as talcum powder, and temperature variations ranging from 127 degrees Celsius during the day to minus 173 degrees at night. Walking bipedally in that environment would be slow and risky. Rolling on well-designed wheels is faster, more stable, and more reliable. The article, published in December 2025, is not mere academic speculation. It is part of a larger set of research that China is developing to prepare the robotic infrastructure needed for the construction of its lunar base. Alongside this semi-humanoid robot, the same Beijing team is developing a second machine, this time with 6 legs, capable of landing softly on the moon and then walking while carrying cargo, functioning as a true lunar truck. These are 2 complementary projects. Together, they form the robotic backbone of the largest space colonization project currently underway on the planet. To understand why this project is relevant, we need to take a step back and explain what is at stake in the design of robots for space. When NASA and General Motors developed the Robonaut in the early 2000s, the goal was to create a humanoid robot that could assist astronauts aboard the International Space Station. In 2011, the Robonaut was sent to space, becoming the first human-shaped machine to operate in orbit. But it had a fundamental limitation. It was installed inside the station, unable to move around. It was essentially a pair of sophisticated arms fixed to the wall. The Chinese project solves this problem in a way that space engineering had not yet consolidated in a single vehicle. The combination of mobility on the lunar surface with manual dexterity worthy of precision technical work. The secret lies in the concept of active suspension. Imagine a car whose wheels were so independent that each one adjusts in real time to keep the vehicle level, as if the ground below were always flat, regardless of the actual terrain. That is the technology the project applies to the lunar robot's wheels. Result: while the wheels tackle rocks and craters, the robot's torso remains stable enough to perform tasks requiring precision, such as assembling structures or collecting samples without contaminating them. The researchers are keen to point out that this choice has a precedent in China's own space history. Both the Yutu rovers, which explored the moon on the Chang'e 3 and Chang'e 4 missions, and the Zhurong rover, which traversed the surface of Mars in 2021, use wheeled locomotion. These programs gave China a vast database on how wheels behave on extraterrestrial soils, and that knowledge is being directly applied to the new robot. But what truly sets this design apart from previous rovers is the matter of hands. Space rovers are great at moving around and photographing, but what they cannot easily do is manipulate objects, tighten screws, hold tubes, or assemble parts. The new robot proposed by the Beijing team has an articulated hand with 4 degrees of freedom, placing it at a level close to that of a specialized industrial arm. For comparison, most rovers have only a simple arm with limited movements, sufficient for digging soil, but not for technical work. The wheels also received special attention to withstand the moon's extreme conditions. The project features a metal mesh structure reinforced with steel trusses, the same basic principle as the wheels used on NASA's Opportunity rover on Mars, but adapted to the even more severe lunar temperatures. This structure offers durability without the weight of solid wheels, as well as shock absorption on uneven terrain. What does this mean in practical terms? It means that, for the first time, Chinese researchers are presenting a robot concept that can both travel long distances on the lunar surface and perform technical maintenance and construction work, something that previously would have required two separate robots or the presence of an astronaut. This is happening now and could change entire scenarios within just a few years. For many professionals and researchers in different fields, the news of the Chinese lunar robot may seem distant from everyday reality. But the impact of this type of development goes far beyond the boundaries of outer space. Let us start with the geopolitical aspect, which is the most immediate. China published this project at a time when NASA faces delays and uncertainties in its Artemis program, the American initiative to return humans to the moon. In February 2026, NASA announced a significant restructuring of the program. The Artemis 3 mission, which was supposed to land astronauts on the moon, was transformed into a test flight in low Earth orbit. The first crewed lunar landing was renamed Artemis 4 and scheduled for 2028 if all goes well. Meanwhile, NASA's SLS rocket has experienced repeated fuel leaks, and SpaceX's lunar lander is still in development. NASA is now under pressure from its own independent oversight agency, which has called into question the feasibility of the announced timelines. China, on the other hand, advances with consistency. In recent years, the Chinese space program has accumulated achievements that, a decade ago, would have seemed unlikely. It was the first country to land a probe on the far side of the moon in 2019. It brought lunar soil samples back to Earth in 2020. It landed the Zhurong rover on Mars in 2021. And in 2024, it returned to Earth with samples collected from the far side of the moon, something unprecedented in the history of space exploration. Each of these missions was a preparatory step for what comes next. The ILRS, International Lunar Research Station, was formally proposed in 2021 in partnership with Russia. Since then, more than 40 institutions from different countries have signed cooperation agreements with China to participate in the project. The ambition is immense. The first phase envisions a functional installation capable of operating autonomously for long periods by 2035. In the second phase, through 2050, the plan is to expand into a network connecting the lunar South Pole, the equatorial line, and the side opposite to the one visible from Earth. In this context, robots like the wheeled semi-humanoid are not just research tools, they are the logistical backbone of the entire base construction. Without them, China cannot build anything. With them, it potentially does not need astronauts to erect the first modules. The dirty work, literally dusty and dangerous, would be done by machines before any human sets foot on the site, and this has direct consequences on Earth. The development of robots with this level of manual dexterity and terrain adaptability feeds an entire technological chain that will be reused in terrestrial applications. Civil construction robots, autonomous workers for hazardous environments, remote industrial maintenance systems. Thousands of researchers and engineers around the world are actively debating the impact of these technologies on the labor market. Professions that today depend on human presence in unhealthy or dangerous environments, such as mining operators, construction workers in risk zones, and industrial maintenance technicians, are natural candidates for automation, accelerated by this generation of robots with enhanced dexterity. There is, of course, an important positive side. Tasks that today cost human lives could be performed by machines. But there is also a real concern about the speed of this transition and the absence of professional retraining policies on the same scale as the technological advances. The race for robotic space dominance is exciting, but it is not free of serious problems. According to experts around the world, there are technical, ethical, and geopolitical issues that deserve attention. From a technical standpoint, the Chinese project presented in the Journal of Deep Space Exploration is so far only a concept. There is no publicly confirmed physical prototype testing this specific design under simulated lunar conditions. The distance between a scientific paper and a machine functioning on the surface of the moon is enormous and full of obstacles. The main one is communication. The moon is approximately 384,000 kilometers from Earth, which means radio signals take about 1.3 seconds to make the one-way trip. For operations requiring quick reactions, this delay can be critical. The robot would need a high degree of autonomy, meaning artificial intelligence capable of making decisions locally without waiting for instructions from Earth. AI embedded in space systems is, in itself, a field of intense debate. According to researchers in the field, the greater a machine's autonomy, the greater the difficulty of predicting its behavior in unexpected situations. In an environment as hostile and unprecedented as the lunar surface, a misjudgment by the AI could damage extremely expensive equipment or compromise an entire mission. There is also the question of transparency. China conducts its space program in a relatively closed manner compared to NASA, which publishes extensive scientific data and allows open international collaborations. Space law experts draw attention to the fact that while the 1967 Outer Space Treaty prohibits any nation from claiming sovereignty over the moon, it is not sufficiently clear regarding the exploitation of resources such as minerals, water, and helium-3, a potential fuel for nuclear fusion reactors. The race for the lunar South Pole region, where there are indications of water ice in permanently shadowed craters, has dimensions that go far beyond pure science. For comparison with other initiatives, it is worth mentioning that the United States is also developing lunar robots. The Artemis program includes autonomous rovers to transport astronauts and cargo near the South Pole. Private companies like Astrobotic and Intuitive Machines already sent commercial landers to the moon in 2024. The difference is that the Chinese robot proposes something more ambitious: manual dexterity for construction and maintenance, not just transport and data collection. The forecasts for the coming years are realistic and, at the same time, surprising. The Chang'e 7 mission, scheduled for launch in 2026, will investigate the lunar South Pole in search of water ice, a resource that can be used to produce oxygen and fuel in situ, drastically reducing the cost of future missions. Chang'e 8, scheduled for 2028 or 2029, will test autonomous construction technologies, including the use of processed lunar soil as a building material, something scientists call in situ resource utilization, or ISRU. If these tests are successful, the construction of the ILRS between 2030 and 2035 becomes technically viable. According to the chief designer of the Chinese lunar program, Wu Weiren, the station will be operated primarily by robots, with astronauts visiting on short missions, a completely different model from the International Space Station, where humans spend months on board. This concept of a permanent robotic base with occasional human visits could become the standard for all future planetary exploration. There is a moment when a technology stops being a project and starts being a destiny. China has reached that point in its space program. The wheeled semi-humanoid robot presented by the Beijing Institute of Spacecraft System Engineering is not a final product. It is a signal that space, over the next 10 years, will transform into a construction site inhabited by intelligent machines, designed to do the work that today would require decades of astronaut training or that would simply not be possible without risking human lives. The narrative of space exploration is changing rapidly. For decades, the image we had was of heroic astronauts in spacesuits stepping onto distant planets. That image is still real. China plans to land its first taikonauts on the moon before 2030, and NASA is working to do the same with the Artemis program, now aiming for 2028. But it is becoming increasingly clear that humans will only be able to establish a sustainable presence beyond Earth if sophisticated robots do the heavy lifting first. What is at stake is far greater than national prestige. The lunar South Pole region, a target of both China and the United States, contains permanently shadowed craters where water ice exists. This resource can be electrolytically separated into hydrogen and oxygen, fuel, and breathable air. Whoever controls this resource will have an enormous strategic advantage in the exploration of the solar system. The lunar South Pole could be, in the coming decades, the spatial equivalent of a fuel port in the middle of the Atlantic Ocean. Whoever arrives first and manages to operate sustainably sets the rules for everything else. In this scenario, robots with the dexterity described by Chinese researchers are not accessories. They are a prerequisite. Building habitation modules, installing solar panels, assembling nuclear reactors, maintaining critical equipment at temperatures of -173 degrees Celsius with a communication delay of more than 1 second. None of these tasks can depend exclusively on human presence in the short term. And, as mentioned before, what happens on the moon does not stay on the moon. Every advance in robotic dexterity for extreme environments has direct application on Earth, in underground mines, in nuclear power plants, in natural disaster zones, on oil platforms. The technology that will erect the first permanent base on the moon is the same one that, in the near future, will profoundly transform how we work, produce, and inhabit the planet. The big question is, who will write the rules of this future? The absence of a modern space treaty, capable of clearly regulating the exploitation of extraterrestrial resources, is a dangerous gap. The race unfolding now, with China advancing methodically, the United States struggling against delays and astronomical costs, and private companies like SpaceX and Blue Origin building their own bets, may or may not produce a future of cooperation and shared benefit. It depends, to a large extent, on the political choices that will be made over the next 5 years. One thing is certain: the century of the moon has already begun, and the first workers of the greatest construction site in human history will not be made of flesh and bone. What do you think will happen when China and the United States compete for the same resources at the lunar South Pole? Will it end in cooperation or conflict? Leave your opinion in the comments. If you enjoyed the video, leave your like and subscribe to the channel. That way, you will always receive notifications of new videos. Until next time.